Lesson 12.2 is about angles in standard position. So standard position means that the angle starts with the positive x-axis. So the angle starts here. That's called the initial side. And then it rotates. The amount it rotates depends on how many degrees it is. So I would say that was about 130 degrees. So the positive x-axis is the initial side. The other side is called the terminal side. Alright, so some things to know. If the angle is positive, so if the angle has a measure that is a positive number, you're going to rotate the terminal side counterclockwise. If the measure of the angle is negative, you're going to rotate the angle clockwise. So some examples. If I do a positive angle, let's say that's 60 degrees. But if my angle is negative, then we rotate the way a clock does, so we rotate this way. And the distance you go just depends on the degree measure. I went more than 180 degrees. I'll call that negative 230 degrees. Okay, so now we're going to sketch these angles in standard position. So the first one is positive 80 degrees. We start with our initial side. We rotate counterclockwise because it's positive. And we know that if I go to the y-axis, that's 90 degrees. So I want to go almost to the y-axis. So I draw a little spiral arrow that shows which way I went. Then I make the terminal side. And let's label what this was, 80 degrees. Alright, so standard position always means start with the positive x-axis. That's your initial side. And because this is negative, we rotate clockwise. I've gone 90, so I need to go 60 more, which is around here. And now I'm drawing the terminal side, and I'm going to label how far it was, negative 150 degrees. So number 3 is more than 360 degrees. So we're still going to start with the positive x-axis as our initial side. Then we're going to rotate counterclockwise. So I've gone 360, I need to keep going. I've gone 450, 540, 60 more, around there. Then I make the terminal side. And I'm going to label how big this was, 600 degrees. So I went more than one lap around. Alright, now we're going to talk about coterminal angles. What does this word coterminal mean? Well, co means same, and terminal means end. So coterminal means an angle that ends in the same spot. So for example, this 50-degree angle, let's say we're here and we decide to run one lap around the track. So if you're at this spot and you decide to go 360 degrees around, you would end up in the same spot. So 50 degrees and then 360 degrees more is 410 degrees. So 50 and 410 are coterminal angles. So anytime you add 360, you end up in the same spot. You can also subtract 360 and you'll end up in the same spot. Alright, so for number 4, we want to find a positive angle that's coterminal to our angle, and also a negative angle that's coterminal with the given angle. So to find the positive one, I'm going to add 360. So here's our positive angle that's coterminal to 15. And to find a negative angle, I could subtract 360. So anytime you're on a circle, and if you add 360, you'll end up in the same spot, and if you subtract 360, you'll end up in the same spot. So if I'm at negative 45 degrees, and I add 360 degrees, I know that I will go one lap around, but I'll still be in the same spot. So a positive angle that is coterminal to negative 45 is 315. And if I want a negative angle, I subtract 360. So negative 405 degrees is also coterminal to negative 45 degrees. Okay, so similar to how we have meters versus feet for length, the way we measure a circle is usually in degrees, but another way to measure angles is a unit called a radian. Okay, so what is a radian? Let me draw a circle. So you guys know that a radius goes from the center of a circle to a point on the circle. So that's a radius. Now imagine this distance from the center to the end. Well, what if we wanted to walk that same distance, but actually instead do it on the circle? How far would we get? I would say we would only get about that far. So that is called a radian. A radian is the same length as the radius of a circle. You have learned a formula for circumference of a circle. You probably learned this in geometry. Circumference of a circle is 2 pi times the radius. Remember, a radian is the same length as the radius. So how many radians are, if we were to walk all the way around the circle, how many radians would that be? That would be 2 pi radians. So 2 pi radians is the same as 360 degrees. So if, and I'll do this up here, if 2 pi, and you don't have to write radians, when you see the pi, that tells people that it's in radians. If 2 pi equals 360 degrees, then pi equals 180 degrees. Alright, so if you're going to convert from degrees to radians, so if you were doing dimensional analysis and you wanted degrees to cancel out, you would take the angle, whatever it is, and you would multiply by pi over 180. So because you want degrees to cancel out, the degrees goes on the bottom. Now if you're in radians and you want to convert from radians to degrees, the radians needs to go on the bottom because you want the radians to cancel out. So you'd multiply by 180 degrees over pi. Alright, so we're going to do 2 examples here. Number 8 is in degrees. If we want to convert that to radians, we multiply by pi over 180. Alright, 120 over 180 is the same as 12 over 18. We can divide both of those by 6, or we could divide these original numbers by 60. So reducing, divide 120 by 60, you get 2. Divide 180 by 60, you get 3. So that is 2/3 pi radians. And you don't have to write the word radians. The pi tells you that it's in radians. Alright, this one's in radians because we see pi. So we need to put pi on the bottom and 180 on top. Remember that pi and 180 equal the same thing. Alright, the pi's cancel. 80 divided by 8, but then we have to multiply by -3. So 180 divided by 8 is 22.5. Multiply that by 3 and you get -67.5 degrees. Alright, one more concept. If you know the measure of a central angle, so a central angle is an angle with its vertex at the center of a circle. If you know the measure of a central angle and the radius of the circle, you can find the arc length which is here. You could find the arc length of the intercepted arc. So let me explain what that means. So we have a central angle, and imagine these lines go on forever, but they intersect the circle here, so this is called our intercepted arc. So the length of that arc is, there's a formula, and they use S. I'm not sure why they use S, but S represents arc length. The formula is S equals the radius times the angle theta. And theta must be in radians if you're going to use this formula. Okay, so we have one example to do. A circle has a diameter of 9 centimeters, so that means it has a radius of 4.5 centimeters. We want to find the arc length. So we're going to use the formula S equals R times theta. R is 4.5. The angle theta, they give it to us in degrees. So we need to convert this to radians by multiplying by pi over 180. 60 divided by 180 is 1/3. So this is going to be pi over 3. Using a calculator, we get 4.5 divided by 3 is 1.5. 1.5 times pi is 4.7. The units are centimeters. So the length of the intercepted arc, the arc length, was 4.7 centimeters. Alright, that's all for lesson 12.2.